Hi, I'm Ben Clegg, and in this video I'll be presenting Gradia, our open source modular hybrid grading system. The motivation of our tool is that automated assessment is always necessary, especially where large numbers of students are present in courses. In addition, we also note that manual assessment still has some benefits, such as providing more bespoke feedback to students, or for gauging how students are performing. Our motivation for this tool, therefore, is that can both of these approaches be combined into a single approach? In order to realize this, we created Gradia, which uses this hybrid grading approach. The tool runs on a local machine, therefore there's no barrier to interacting with students' programs directly. This is particularly important for assessing students' programs which use GUIs. Other modern grading approaches tend to be web-based, which means that they can't necessarily interact with these solutions directly. Solutions are graded using a series of modular checks, which I'll discuss in a moment, and Gradia is available on GitHub under the GPL version 3 license. Checks each represent a single grading criteria. They are configured using JSON files, and they are modular, allowing for varied grading functionality. These include unit tests, static analysis rules using, say, PMD or check style, and using manual grading, which again we'll discuss in more detail in a moment. The solution's execution yields a normalized score for each of these checks between 0 and 1, and these are then adjusted according to predefined weights to influence the final grades. These weights can also be modified after grading to tune the grading of every solution. The checks also provide feedback. This is mapped from the normalized base score ranges of the checks. For example, for a check evaluating the quality of variable names, if you had a score between 0.9 and 1, the feedback may be your variable names are informative, whereas lower scores would inform the student that they need to use more informative variable names. Tutors can also add ad hoc feedback for manual checks. So when they are running the manual check, they can specifically give one student solution specific feedback according to the context. In this case, say for example, the particularly poor variable name, the letter A, may be suggested for replacement. In this demonstration of Gradia, we'll be using simulated solutions for a simulated assignment. And we'll first be using automated checks to run unit tests on these solutions. Gradia first compiles all of the solutions to the assignment, including a known correct model solution. It then compiles all the unit tests, and then executes every check on the model solution to ensure that they're all correct. After this has been checked, and the correct checks are retained, it will then go on to evaluate the checks for the student solutions. In this case, we begin with a solution which has bad functionality and will fail some of the tests. And then it will go on to the other solution. In this case, we have a solution with style errors, which will fail some static analysis checks. As you see at the end, it generates a grade based on these checks. I will now demonstrate the manual grading that Gradia provides. You can use a separate configuration file to do this, as this may be beneficial. For example, to run the automated test first to ensure that the student solutions execute and run properly. And once you've checked this, you can run the manual solutions afterwards to save yourself time. First, the tool outputs the command line trace of a program, as you can see on the left here, and it will also open up two files, the first of which contains results of the tests, and the second of which is a merged version of all the source code for the solution. In this case, we only have one source file, so this file only has that one source file. In this case, because this program only has poor functionality and the manual check in question is checking the quality of a variable name, we'll be giving this solution a 10 out of 10, and we won't provide any additional feedback because it isn't necessary. As you can see, the table is printed out, which displays the end feedback and the unweighted score for each manual check. I will now demonstrate another one of Gradia's features, which is state restoration. Whenever a solution is executed by all the checks, the results of these checks are stored in a separate JSON file, which contains the score and the feedback for each of these checks. Gradia can then use these to recover the state of the grading process for every solution that's already been graded. This would allow you to, say, pause the process and come back to it again at a later time, or to recover from a system failure. As you see now, I will close Gradia by exiting, and I will restart the grading process. And as you can see, the first solution's check results are restored through this process, and this is skipped entirely, and grading resumes from the second solution. In this case, we see all the tests pass, but we do find that there's a variable which is poorly named, namely with just the letter X. So in this case, I'll be giving it a score of 6 out of 10. and I'll be entering the feedback to reflect this, in that x is not an informative variable name. In this case, the variable name top floor would be better. Again, the results of these checks are displayed before confirmation, and the grades are outputted just for these manual checks. The other benefit of state restoration is that it allows all of these separate runs of a program to be merged together to get a final grade without any additional post-processing. Here I'll be running the tool again with every check enabled. The system recovers all of the results of the checks immediately. No more checks are executed on the solutions, and we have final grades for both of these solutions. These final results are also stored in CSV files, which provide more specific details of individual checks for perhaps some post-processing if it's necessary, and the single file which contains all of the grades for every solution and all of the feedback for each solution. In our paper, we also present a case study on Gradia, in which we use the tool to assess an end-of-year introductory Java modules assignment. This assignment had 171 student solutions, and students were tasked with parsing files, constructing queries on the parsed data, and displaying any results in a GUI. This would be a perfect fit for Gradia, since it has both many aspects which can be automatically graded very easily, but it also has some aspects which require some form of human intervention to evaluate, such as the layout of a GUI. The module lead, Maria-Cruz, my co-author, used Gradia to mark this assignment, and she used 54 checks, including 26 unit tests, 6 PMD static analysis checks, 6 check-cell static analysis checks, and 7 manual checks. These manual checks were particularly focused on the functionality of the GUI and some aspects of code review which were hard to automate. During the execution of this assignment, we found that Gradia was able to evaluate the students fairly quickly, with compilation only taking around 1.6 seconds per solution, and the automated checks taking around 30 seconds per solution, and the manual checks taking around 2 minutes per solution. The module lead also performed some post-processing on the results, using the CSV files outputted by Gradia. In these cases, she added more specific feedback for the students. This was before Gradia had the ad hoc manual feedback feature, and as such this was necessary. And she also adjusted the weights of some of the checks. For example, some checks produce a higher variance of scores between different students, and therefore increasing the weights of these checks can help to reveal differences in students' performance in their final grades. Examination of these CSV files also allows for general feedback to be provided to the whole cohort of students, such as any particular checks where most students failed or where some particularly common problems were prevalent. In this case study, we found that Gradia offers several benefits, one of the key ones being that it allows for the fast manual assessment of student solutions. This is mostly due to the solution inspector, which automatically runs the programs and shows the source code to the tutor. In this case, we were able to automatically execute the GUI and interact with it. Naturally, automated grading is beneficial too, where any manual assessment that is required is minimized. So, for example, using static analysis to evaluate the quality of students' code wherever possible. Gradia also provides students with high-quality feedback. The large number of checks allows us to provide feedback for a wide variety of learning outcomes. Faulkner et al. Have shown that more automated feedback can improve students' learning. This feedback is also augmented by the provision of manual feedback. We did, however, find some challenges in the case study. Particularly, uncompilable student solutions are particularly problematic and require a significant time cost, each of these taking 20 to 30 minutes to resolve. Perhaps we could integrate Gradia into the web-based submission system to automatically check that student solutions compile and execute. We did, however, find some limitations in the test execution environment of Gradia, where tests take longer to evaluate than necessary. We'll plan to address this in the future, though we do find that multi-threading significantly reduces the problem. In conclusion, we find that Gradia offers an alternative to web-based automated grading, and that the hybrid approach offers many advantages by combining manual and automated assessment. We also note that Gradia is available on GitHub for free under the GPL version 3 license. You can try the tool out today if you would like, although we would note that the tool is under the early stages of development, so any suggestions or any contributions we greatly welcome. We also plan some future work for the tool, particularly to add a GUI to the tool itself to improve usability for tutors. We also plan to add some form of web integration to the tool to check that the student solutions execute and compile at submission time and allow us to inform them if they have any severe issues, and to increase the modularity of the system, such as increasing support for other programming languages and custom testing environments. Thank you very much.
Hello again. We are here in the QA part of our third paper. Benjamin Clegg is here to discuss with you and answer your questions. So we already have one question by Walter. He says, I might have missed this, but does this require a student's project to be in a certain structure? For example, ORs have a Gradle build files instead of Maven.
Hi everyone. So thanks for the question. In this case, no, we don't require you to use like a particular build system. While Gradia uses a build system itself currently, as long as the students' classes are in a expected package structure, which is defined by the tutor in advance, then it should be fine. No issues there. For example, say if you had like a assignment dot semester one dot and then a class name, that would be fine.
Okay. So more questions are welcome. Please write them on the chat. In the meanwhile, I have another question about the limitations in the text execution environment that you mentioned. If you can elaborate on this.
Yeah, so currently the current version of Gradia uses the Ant build system to run tests and to compile classes, etc., which is a bit of a hindrance. It's not the best tool for the job anymore. The main concern that I have with it right now is that you can only evaluate test results on a test class basis. So say if it will tell you how many tests in a class fail, but it doesn't tell you which tests fail. There might be some way of doing that with a plugin or something like this, but I haven't. I have sadly been too limited on time to work it out. But I currently have plans to essentially ditch Ant altogether and move to like a more custom system for executing tests, which should also support the languages as well. It should be more modular. While the system is a quote-unquote modular hybrid grader, it could be more modular, which is the intention for the future.
Okay, cool. Then I have another question about if have you considered to give the tool to the students so they can assess by themselves, at least for the automatic part of the assessment?
Yeah, we had. I've been in discussions with the module lead that runs the Java course about this. Currently, we haven't deployed that yet. We were thinking about doing it for this semester, but it was a bit too tight on time, unfortunately. I think the plan is for next semester to give the students like a stripped down version of the tool, which, for example, not just so that they know it's at least in the right structure. I think the main concern of us right now is that currently students have to submit a zip file to an online repository. So we'd want to have some form of system to automatically extract that. So it kind of automates that process. And ideally in the long run to integrate it with the courseware itself. So that it's automatic and just done on the server somewhere.
Okay, good. Then I have another question. The grader is for Java only.
Yeah. Currently, because we're teaching a Java course. Sorry if I cut off there. It's because you already mentioned the question before, so I kind of a bit too keen. Yeah, currently because we're teaching a Java course, our predominant focus is on Java assessment. So naturally, we probably would focus on this first. However, because of the way that checks are modularized, while it's held back by the current use of Ant, I think that it should definitely in the future be possible to just support any language. That's, again, the intention. Not quite there yet, but in theory, like the check system, for example, would just support any language as it currently stands.
Okay, good. Okay, so we still have 5 minutes for questions or comments. Is there any other question or comment?
Yeah, I'm happy to make any clarifications as well. If anyone has anything that's a bit confusing, I know the video is a little bit quick. So.
Yeah. Which do you think that is the main challenge for you as teacher in this experience?
I think that the main challenge we've probably found is that it's kind of a case of that students usually submit a broken version of the assignments to say like their packages are wrong or they're using dependencies. No matter how much we tell them
Yeah.
or how much we try to drill it in that, do it this way, there's always about, I'd say, maybe 10% of people who choose to ignore that. So I think that's probably the most frustrating challenge. And I see another question in the chat as well.
Okay, good. We have another question here. Could this be integrated into something like Jenkins or GitHub Actions as an automated build step?
That's a very good question. I think that essentially because you can choose to run the tool headlessly if you're not using manual checks, which is this interactive question system, or you're not doing GUI testing, I don't see why you wouldn't be able to. I think the main, I wouldn't say it's necessarily built for that right now, because in the current version, it's assumed that you have like a batch of solutions that you run, but there's nothing stopping you from, say, running like a GitHub Actions to essentially prepare that and move one solution as a quote-unquote batch of solutions to essentially just run the tool on that. I think that should be doable without too many issues. The current, again, I have more plans for further development of the tool, which would be to kind of follow more of a pipeline process so that individual solutions, it's considered on a solution-by-solution basis. Yes, yeah. Yeah, great. I think that there are certain things that we have noticed are more efficient. Again, Ant's kind of held us back a little bit, so I'm really keen to get away from it. But we have noticed that, say, manual assessment, we've received, aside from some teething issues with technical issues, we have seen like it's a lot more efficient to just run the code and see what the code is, and then answer questions based on that. It's much quicker. We don't have any timings for it right now, I don't believe, because we don't have a timing to compare it against. However, like the module leader's given me a lot of feedback and said, yeah, this is a lot quicker than doing it all manually.
I don't remember if you have mentioned it in the paper, but the tool is available somewhere?
It's on GitHub. I believe in the paper there's a link to it.
I don't remember, sorry.
Yeah, if you click my name right now as well, you'll see a link to my GitHub page, and it should be like the top repository there.
Okay.
So yeah, it's free to download right now. I think, again, it's currently in early stages, so it's a little bit finicky, but I'm happy to answer any questions people have. Like if people want to set it up on their own course, I'm happy to provide some form of assistance.
Good. Okay. So 1 minute, 1 minute and a half. Is there any other question or comment for Benjamin? Okay, if not, so we have 1 minute for to take a rest before the next paper.
I can probably fit one in 30 seconds, I reckon. I can probably answer one pretty quickly, hopefully. Okay. Again, I'm happy to take any offline as well if I'll be around here for another 5 minutes or so in the chat, just in case anyone does have any that they're still typing out or whatever.
Okay, cool. So thank you very much.
Yeah, thank you.
Thank you, Benjamin, and thank you for all the questions and comments. Okay, I will leave the session, go to the next one. Thank you. Enjoy the day.
Thank you very much. Have a good day.
Bye.
Bye. Great. I'm happy to hear that, Nelly. Again, yeah, feel free to contact me if you want any advice on setting it up. Yeah, I believe my video will end in a couple of seconds, so if anyone does have any more questions, I'll be around for another 5 minutes to answer them on the chat room. Yeah, thanks for all watching it. Cheers.